Hello, everyone. So we're going to start this webinar now. My name is Ali Reza. I'm one of the geomechanics specialists at Rocscience, and I have with me my friend and colleague, Dr. Sina Jamal Khoshtal, another geomechanics specialist. The two of us together, we will present this webinar for you on RS3, and we will try to answer as many questions as we can at the end of the presentation. So a brief introduction of the company, Rocscience. Rocscience is a world leader in developing 2D and 3D software packages for civil, mining, and geotechnical engineering applications. And we have more than 20 years experience in doing that. We have more than 7,000 customers all around the globe in more than 120 countries. And we have more than 450 universities that are enrolled in our educational program. Currently, at our main office in Toronto, Canada, we have more than 40 employees. More than half of us, we have advanced degrees in engineering. In Rocscience, we are developing geotechnical tools and software that are inspired by our users, and we will tailor design our program and softwares. We add features to it depending on the feedback that we receive from our customers, and we try to meet our expectation from the users, and we try to include as many features as possible for our users. We have a family of packages, tools, 16 total tools that we have. We can categorize them in different sections. We have tools for slope stability, the bunch that I'm showing you at the bottom here. So, for example, slide 2 is one of the most powerful packages out there for 2D limit equilibrium analysis. You can do support design in it. You can do groundwater analysis, steady state, transient, and we have many new and advanced features in it. For example, we have a spatial variability analysis in slide 2. Slide 3 is the 3D limit equilibrium analysis. We have lots of tools to generate completely 3D geometries in it. You can use it in analysis of open pit. You can import slide 2 files and extrude it and do analysis in 3D form. And we have many options for search algorithm and methods that we can solve the slope stability problem. Rockplane, this is one of our simple programs. This is for planar wedge analysis for a slope. You can do include pore water pressure in analysis, ponded water load. You can do very fast probabilistic analysis on it, and you can use it to do support design. And also, we have different options for viewing the results as well. S-wedge is for surface wedge analysis for rock slopes. Again, similar to Rockplane, it's quite a simple program. You can do very fast analysis with it. You can do probabilistic analysis, support analysis, and we have many options for surface wedge analysis, including interaction of the water with the slope. Rocktuple, another simple program. This is for specifically toppling analysis. You can do probabilistic analysis, support analysis, and you can do toppling analysis considering different modes of toppling, including tension and toppling analysis. Rockfall is for a statistical analysis of rockfalls. If a piece of rock separates from a slope at the top, the path that the piece of rock is gonna take to come down to the downward in slope, you can analyze it, animate it. You can do statistical analysis on it, and you have many options to design your berms, your fences, and also include so many damping options like forest damping in the simulation. Then we have another set of tools for excavation. These include like RS2, our 2D finite element program. You can use RS2 for tunnel excavation design. You can do groundwater analysis, seepage analysis, steady state, and transient. You can do coupled analysis, considering the hydromechanical coupling of solid skeleton with pore fluid, and also applying the shear strength reduction method on finite element. You can actually evaluate the factors of safety or and compare it with the results that we are getting from the limit equilibrium analysis, for example. RS3 The focus of this presentation is our 3D geotechnical finite element package. All the features that we have in RS2, we have it in RS3 as well. You can use it for tunnel excavation, support analysis, groundwater analysis, hydromechanical coupling, and we also have the shear strength reduction method similar to what we have in RS2 as well. Rock support, this is for support estimation using ground reaction curve. The base of the software is a analytical solution, and you can use it for support analysis design. It's quite simple and handy package. X3 is formerly known as Examine 3D, is for 3D stress analysis of underground excavation. With this one, you can have a design, you can evaluate the isosurfaces around the excavation. You can evaluate the stress and stress distribution around it. And the new features that we have in it, you can have multiple materials in the domain, you can have joint, and you can stage the excavation as well. Unwedge is similar to what we had for rock pulling and S-wedge, but this one is basically designed for underground wedge stability analysis. Similarly, you can do many statistical analysis here as well. And besides the first two sets of tools that I mentioned, we have another set we call them geotechnical tools. These include Settle 3D. This is settlement and consolidation analysis. The basic formulation behind it is the Terzani consolidation theory. You can have time-dependent consolidation. You can define your model using non-horizontal ground surfaces, fully 3D geometry, and we have a powerful CPT module in it to do CPT analysis and also liquefaction analysis. RS-Pile is one of our newest packages. With this one, you can do pile analysis, individual pile analysis, or group piles. You can do lateral pile analysis, and even also you can do driven pile analysis. And integration of RS-Pile with slide 2, using this interaction that they can do, you can evaluate the support forces of piles accurately and use them in your slope stability analysis. Rock data is the package that we have for rock, soil, and discontinuity strength analysis. The failure criteria that is applied for this kind of material, the famous one, are included in this. You can evaluate your failure criteria, analyze it, check it with rock prop properties, for example, which include a database for the rock properties. Also, you can use it for curve fitting to triaxial lab data or direct shear test, and evaluate your strength characteristic, and then use them in your more advanced simulation in RS2 and slide, in our finite element packages or the limit equilibrium analysis. C-Pillar, another simple program. This is a crown pillar stability analysis. And DIPS is for graphical and statistical analysis of orientation data. These are mostly the joints in rock masses. You can do a stereonet graph, 3D stereosphere. You can do simple kinematic analysis with it, and you can have many options for plotting the results. Now, lately we have been going towards 3D softwares, and we are trying to provide comprehensive, all-inclusive 3D products for the most challenging geotechnical problem that let our users create their models, design it, and also use the results in their analysis. Now I'll pass the presentation to my colleague Sina. He will be talking about model creation in 3D. Thank you, Sina.
Hi everyone, my name is Sina Javan Khoshtel, and thanks Alireza for the start of the presentation. He's going to come back for demos. Let's talk about model creation. There are different ways of creating models in the RS3 software. Model creation actually is similar in RS3 and Slide 3. Both are 3D geometry software packages. So I'm going to start with the simple ones, and then we go to the more complicated ones. The simplest way of creating geometry or models are by drawing polylines, two-dimensional polylines, and then use different tools to change the polylines to surfaces and volumes. You can use these draw polyline tools that we have in the RS3 software. We have different options like freehand manipulation or using freehand option to draw the polylines. You can import the points, coordinates as a table, or you can input them in the software. And you can have different path definitions like arc, curve, circles, and other cases. We also provided typical shapes in the software, such as box, cylinder, cone, ellipsoid, plane. For example, box and plane are extensively used to create 3D models. So these are included in the software, and you can add them with different sizes. After drawing or importing polylines or creating surfaces, there are different ways of creating volumes in the RS3 software. For example, you can extrude the polylines in a vertical direction in any plane that you want, or you can sweep the polylines along the defined path, or if you have two polylines facing each other, you can create surfaces and volumes using loft options. So these are very handy options in the RS3 software. After creating these surfaces and volumes, a lot of times you want some sort of transformations. For example, you want to move the pieces of geometries that you created, you use the translate option. You can rotate them, and you can change the sizes using a scale option. These three options are fixed options. But we have one option called freehand manipulation that you can change the size, rotate, or move the pieces of geometries freely, so you don't have to put numbers. Borehole Manager in the RS3 software is one of the very handy tools that we have in this software. You can add as many borehole data as you have, and then when you have the initial piece of geometry, this borehole data is gonna be applied to the geometry. And for example, for this piece of geometry, which is a landslide, the borehole data is gonna be applied to the geometry, and the software is gonna create regions based on the borehole data and do the interpolation. You can also import surfaces to the software. There are a couple of surfaces in different formats, for example, point cloud or elevation contours. Point cloud surfaces, as you can see here, we added the surface to the software, which was in a DXF format, and then we use these tools in the software to change the point cloud to a surface. Or if we have elevation contours, like this, you can change the elevation contour to the surface in RS3, which is very simple. After importing surfaces in the RS3 software, the first step is software is gonna check the surface for defects or problems. And then we have different sets of repairing tools to repair the surfaces that we input to the software. The first group of the repair tools, these repair tools are looking for defects in the surface, and they're gonna fix these defects. Also, we have surface triangulation tools. All the surfaces and volumes created in the RS3 software, they are all triangulated surfaces and volumes. But sometimes these surfaces, they don't have a good triangulation, and this triangulation cannot help us to create a geometry, a 3D geometry. So they have to be fixed, and we use these tools. For example, let's look at this pit surface that we have. Let's check for the defects, and you can see we are looking basically for 5 different defects. The most important ones are holes, self-intersections, and non-manifold problems. The obvious one is the hole on the north side of the pit surface. The easiest way in the software now is to fix these problems, and we just need to click on repair button, and all these problems are going to be fixed. For example, if we click on repair, you can see all these defects are fixed. As I mentioned, these surfaces are all triangulated surfaces. You can see here that these are surface triangulations. you have to keep it in mind that we have seen a lot of surfaces from our customers that the triangulation is very dense, and if we try to create a geometry using a very dense triangulation, first of all, the computation is going to be very extensive, and also the chance to have bad volumetric mesh is going to be higher. That's why you have to modify these triangulations, and you can use the fine option or you can use the coarse option, and you change the triangulation. I have to add this that repair tools, the one that I showed before, by clicking on repair, we do one step of retriangulating the surfaces. But if you want to modify it more, you have to use this simplify triangulation option. After adding all these surfaces and volumes and pieces of geometries, you have to combine them, cut them, divide them to create one final model. To do that, we have these 3D Boolean options, including union, which joins the pieces of geometry, or divide all geometry, which creates material volumes and creates external volume. We have to use these options, and we're going to show you how to use these options in the 2 demos that we're going to show after my presentation. And the final point about creating model is we have 3 different roles in the RS3 software: geology, excavation, and construction. All the computations will be carried out on geology and excavation pieces only, and the software ignores the construction pieces. For example, in this tunnel in the box, the lower box is geology, the tunnel has the role of excavation, and the top piece has the role of construction. So when we do the computation will be done on the tunnel and the lower part of the box, and the top part of the box will be ignored. The advantage of this construction role is that when you have a complicated geometry, there are pieces that you don't want them to be in the computation procedure, and you can change the role to construction, and the software is gonna ignore them. So Ali Reza is gonna continue with the demo, and I'm gonna come back with the next.
Thank you, Sina. So I just wanted to mention that the RS3 that I'm using today is the latest version that is actually going to be available to customers by the end of the month. The first demo that we will show you is of a tunnel and a raft foundation. This is the final version of the model, and I will be using all the tools, geometry tools that are available to me within the RS3 itself. I will not import any piece of geometry to create the geometry. So as you see here, I have the raft foundation, and I have a tunnel, and I have different layers of material in my geology. I have 2 stages. Initial stage, the assumption is that we have the material in the materials of geology and also the tunnel, and we are actually looking to see what is the effect of the raft foundation, the piled raft foundation, and the load that is applied on top of that to the domain. So I will start this from an early stage of the model. So I have the initial file here. I'll open it in RS3. When opens, the entities that I have in the model at the beginning are my 5 boreholes. With boreholes, what I would do, I will use them to generate the geology layers, and also I can show you what materials are being defined and used in the model. So I have these 5 boreholes. In the borehole manager, you can see that these 5 boreholes are defined. They are defined using the location, trend and plunge for the orientation of the borehole, and all the materials that are included in the definition of in this borehole and with their thicknesses. What we see here, as I go through different boreholes, you can see the thickness of the material are changing. The tabular value that you can see here, you can copy paste easily from any other softwares, for example, Excel. You can easily edit all these entities here. The material layers that I have here are including medium sand, silty sand, dense silty sand, and silty clay. I will show you the properties of the material next. And we have borehole setting, how to interpolate between these boreholes and create the layers. You have the option of generating the top surface and also the bottom surface. I'm not doing that here. I will be using an external box to generate these two surfaces. So let's assume that I have these boreholes. This is the location and orientation. Okay. So the materials that we have for the geology, these are accessible from defined material. We have all these 4 materials that are used. The last one is not used in the domain. They are defined using initial condition, unit weight, and initial element loading. All of them, they have strength criteria, stiffness. If there is something changing of the material properties throughout the stages, you can stage them here. If any property is datum dependent, you can define them here. And if you are doing groundwater analysis or any kind of pore water pressure exists in the domain, you can define it using the hydraulic properties here. Okay. Now, the model includes geology layers, tunnel, and a foundation. So these geology layers basically are defined here. What I'm going to do now, I'm going to use the geometry tools that we have in RS3 to create that tunnel geometry. So I'm going to geometry, RS tools, tunnel profile. Within this dialog, we have many typical tunnel sections. As I'm clicking through them, you can see them. And the one that I'm going to use today is the horseshoe tunnel. And I'm going to use the same default parameters that I have here. It's roughly 6 meter wide and 6 meter high. I'll bring it in. When bringing these pieces of geometry, you can see it here at this corner. You can position them properly and also set the direction for them. But since I'm just going to use this profile and sweep it along a path, the path would be the axis of the tunnel. I'll just bring the section here and I use the profile, the path to extrude it along that. So okay to this one. Now I have the section here. You can see it's highlighted in red. And then I will bring the polyline, use the polyline tool to create the sweeping path, the path that the tunnel will follow in the domain. So I'm going to go to draw polyline. The tunnel is going to be horizontal, so I'm going to define my path in XY plane. I'm going to zoom out a little bit so that you can see where the path is going to be. I will use the 3-point on arc option. The tunnel is going to be curved going through the domain, and the coordinate that I have for those 3 points are -40, 25. I can enter the coordinate in the dialog here, 22, 22, and 80, 0. So the path is created for you. You can see it in the view. So this is okay, done. And now we have the tunnel profile and the path that I would like to use as my sweeping path. So I will select both of them. I'm holding control, clicking them in the visibility tree. Both are selected. Then I will go to sweep option, and I'm making a closed volume. The profile section is the one, the horseshoe tunnel, and I'm sweeping it along that polyline, the curved polyline that I defined it. The only thing is that I can position it at the location that I want. I want the tunnel to be 20 meters below the surface. I can preview. So now I have the tunnel 20 meters from the top elevation, 0. The geometry is created. Okay. Now, flow of creating the model is actually these arrows. So geology, excavation, support, groundwater, load, restraint, mesh, compute, and then look at the results. We are still in the geology tab. The pieces of geometry that I define here, they're only the layers and also the excavation of the tunnel. What I need to assign the extent of the model that I would like to solve. So doing that is usually we need an external boundary. That's gonna limit the extent of the model that we are putting in the finite element program. So there are many options for that. What I'm gonna use here is the external box. Again, for the external box, there are options here. I'm gonna use the 2 corners. So I'm gonna give the coordinates of the 2 opposing corners. I can enter the values directly here, or I can go within the domain and actually manipulate all these contours, all these points manually as well. But I have the coordinates here. I'm going to put -30 here, -30, 70, 70. And as you see, I have rather appropriate size domain that I'm going to contain all the model aspects within this box and solve it for this. So this is okay. Now, within the visibility tree, you can see that I have the external and it has a lock icon in front of it. Anything that has a lock icon in front of it means that it is included in the model, and all these pieces of geometry, these entities, they are included in the finite element model, and the simulation is going to solve that problem. Before going forward with this, if you have any questions, you can type them in the question section. At the end of the presentation, we will be addressing as many as we can. Okay, so I have the external and I have my geology layers and the tunnel section. To make them interact with each other and give me the pieces of geometry that I need, I can go use the divide all function. This is going to use the layers that we define using boreholes and also the tunnel section, and all these pieces, they will interact with each other. The material definition in the domain is majorly defined by the boreholes. As you can see, I can show you the materials using a cutting plane. So these are the material assignment using the boreholes. If I do a cut section, you can see that like the tunnel is using material 5, for example. You can excavate it here, any of these material that you can see on the left, you can pick them and assign to any of these zones that you would like. Okay, let's say I excavated a piece of tunnel in this dialog. Okay, now tunnel itself, after doing the divide all, has been divided into 3 sections. I can select out these 3, select the first one, hold shift, select the last one, and I can assign the material to all of them as no material. I'll change the role to geology. In cases that you have multiple stages of excavation and you would like to replace the material or excavate the material stage by step, it's better to have it as geology, then assign no material as your stages of excavation go forward. So I will change the role to geology, assign no material to it. And just to clean up the geometry, as Sina will also integrate later, and cleaning up geometry is very important aspects of this model creation. And it's going to help the meshing algorithm a lot, and you will have valid mesh so that you can use it in your finite element calculation. So these 3 pieces, I'm using a Boolean operator on them, union, and all 3 of them, they will be joined together as one piece and excavated at one stage. Now, if I go through the material assignment again, XY, and I use my cutting plane, you can see that the tunnel is going through the domain through different layers, but in all of them, it's one volume and it's excavated. Okay. Now, the next step would be defining the foundation, the footing, and that is going to happen. That is going to be introduced to the model in the second stage. I can go here and click here. I'm adding a second stage here, or I can go to project setting, and in stages, I can use 2 stages or any number of stages that I have, depending on the sequence of the model. I can rename the stages. This is going to be the initial, when I have the tunnel, and the next stage is going to be foundation and loading. Okay. To develop the geometry of the foundation, again, I'm using one of those primitive geometry tool. All I'm doing here to create the geometry is all the tools that I have available to me within RS3 itself. So I will make a rectangular box for the footing. So this is the preview of the box. I want the box to be at minus 15, 25, 25, and to the depth of 2 meters below the surface. So the foundation is actually on top of borehole number 3 almost, and on top of the tunnel. And I'm creating the piece of geometry here so that I can interact with it later to assign my support element, the liner element, create my footing, and also assign my piles to make that pile raft foundation. There are different ways to do this. What I'm doing here, I'm creating the geometry with this box. Okay. Now this box still, as you see, there is no lock icon in front of it. It's not interacting with the model yet, so I have to go do another divide all. Now it has the lock and it is interacting with the domain. I'm going to actually rename this one to footing, and I'll change the material to the original material that we had. You might want to excavate it and pour concrete there, but in this case, I'm using the same material. I'm bringing the foundation, the footing, as a liner, and define the properties of the concrete to the liner. Okay, so this is good. Now, I would like to go to support tab and bring in my support elements. Within the support tab, let me show you what I have defined in this model. For the liners, for individual liners, I have defined a footing, which is using typical properties of concrete, thickness of 1 meter. I have another liner for liner element for tunnel liner. I'm not using it, but I just wanted to show you that you can create any number of these individual liners in the domain. And on top of individual liners, we have liner composition. Like the raft foundation is a lining composition. You can have many number of virtually unlimited number of these individual liners piled up on top of each other, and you can stage which layer is going to be introduced to the model at what stage after the previous layer, for example. You can create all these different layers for your composite liners. Okay. Now, I would like to assign that liner to the top of this square. The area that I'm looking at is rather crowded. Let me double click on this, select my entities. I'm going to hide some of these entities so that I can focus on the foundation. So this area is the one that I would like to assign the liner and piles. I'm going to go to face selection. I will select the top face, and I am adding the raft foundation on top of this area at stage number 2, which is foundation unloading, and OK. So now if I select this raft foundation, you can see that it is color coded depending on the stage. It's not present on stage 1. In stage 2, it is in the domain. Now I'm going to hide this one as well. Within the same stage, I'm bringing in a series of piles to make the pile raft foundation. Let me just show you what kind of pile I'll bring in the domain. The piles are defined here. The pile raft foundation, you have the properties of the beam element for the pile. You have the connection between the cap and the piles, and you have the pile properties, base normal stiffness, base force resistance, and also the skin resistance. All of that is defined here. And the beam that we are using for the pile, it's the beam pile raft foundation. It's circular area. Again, I'm using properties of the concrete for it. Now, to bring those in, again, I will have to assign it to a surface, for example, here. I am in surface selection mode. Select this surface. I'm adding piles or four poles, and I will be adding pile pattern. They will be normal to the surface that I'm defining them for, and the directions of I mean and I max is going to be the same because it's a circular section. The length of these piles is 15 meters. They will be introduced to the model at the second stage when we have the foundation unloading. And for the pattern, I will have this point as my starting point of application, and one of these points as the end point. And what I would like to do is I'm placing 3 by 3 rows of piles. So the distance between the piles is going to be 2.5. offset 1.25. And for the primary path, by default, it is normal. For the secondary path, by default, is going to be normal to the primary path, which is actually what I would like. I would use the same settings, 2.5 spacing, 1.25 offset. You can preview the pattern. So these piles are sticking out of the model. I can flip the direction, preview again, double click. In all 4 views, you can see the piles are defined properly. You will add them to the model. And done. Okay, so now I have the geology, the support all included in the domain. We go to the loading tab. We don't have any groundwater here. In loading, first thing first, I will define the field stress. My field stress is going to be gravity option. And for the K0 for horizontal in both directions, I'm going to use the K0 factor of 0.6. You have many options. If you want different values of K for different materials, you can use this option. Now, the loading is defined. We have to apply the load on top of the foundation as well. I will select the surface again. At any of these views, you can select it. I will add a load to this face that I selected, 200 kilonewton, normal to the surface. And the load is coming at the second stage. Okay. Now for restraints, the next tab, let me bring back all the pieces of geometry. What we can do, any piece of geometry that you can select, you can assign different restraints for it, but I will use the auto option here, auto restraint surface with rollers on the side. That's one of the easiest options that we have in most of the models that are close to the surface. We can use this option, and all the fixities are assigned to the model. The next step would be meshing. The mesh options are available here. The type of element that we are using, the mesh generation, is going to be graded or it's going to be uniform. We have, as usual, in our finite element program, we have the one-click mesh. I just click this, and the mesh will be generated for us. It's quite fast, considering the 3D complex geometry that we have here. It's going to take a couple of seconds. Now the mesh is ready. I have close to 100,000 elements. Now, just let's take a look at the mesh that we are using here. I'm going to cut it with a YZ plane, for example. Okay, it's going through the middle of the domain. And as you see, the mesh is fine around the excavation of the tunnel, but the mesh size, the element that I have around the footing in both these views, are not fine enough. What I would like to do here, I would like to use finer elements around these two entities where the area of my interest is. So I'm going to delete this line. You can assign. Let me turn off the mesh so that we can visualize this option better. I'm using mesh refinement region. For the mesh refinement region, the box that I'm going to create now is going to be the area that the size of element will be defined to the specification that I will ask for. So let's put minus 25 so that it's going to come close to the tunnel. Surface go to 0. Let's extend it in X and Y direction as well. 5, 5, 35, 35. So the box is going around the foundation to contain that area and also extend it to the tunnel area. So this is the area of my interest. Okay, and done. The foundation itself was 10 by 10. The element size that I'm going to use here for refinement, let's say I'm going to use elements of the size 2 meters. Now I have the refinement area assigned. This one, I'm going to go remesh. It will take just a little bit longer because we have the original mesh and then we have the refinement areas. But yet again, you can see that it's quite fast. So now I have 123,000 elements. Let's look at the same section cut as before, YZ plane. And let me just show you the section cut again. You can see we have very finer elements around the area that we are interested in. The next step would be to save and compute. Let's go save the model. Any name that you would like, you can save as. Saving here is going to save the model. Going to compute tab, the calculator for finite element engine is available to you. You can click it. This one is going to write the compute file for the finite element engine, and then launch the engine and execute the compute file. The model has 2 stages. It's quite fast. We are using multi-threaded process. All the CPUs are being used on this machine. The simulation is really fast, and the results are available for us rather instantly. You can go to the results tab, and the components that I had in this model, I had solid elements, beam, and liner elements. All these results are available to me. Let's take a look at displacement, for example, solid displacement, Z displacement. You can look at contours of excavation, or you can have a section cut as YZ plane as well for the contours. And you can select any of the entities that you have here and hide them. Let me hide all geometry and just show you the excavation contour and the contour plane. Now, the focus in this example was, for example, on the focus was on the results that we are getting in the effect of foundation, the displacement that we get from the foundation, and the assumption was that the initial stage was the one that we had the geology and the tunnel. So let's go to, if you want to only look at that effect, you can go to reference stage and set your reference state to initial, okay? And now the displacement that you are visualizing here is only the Z displacement because of the footing load that is being applied on top of the load that is applied on top of that pile draft foundation. We have all the other results available to us as well. For the liner, for example, let me bring up the liner. So the liner displacement, for example, let's look at the Z displacement for the liner. These are also available to you. And let me reactivate the piles. If you would like to take a look at the results from the piles, you can go to beam and pile results, and let's look at, for example, the axial force of the piles. And any of these piles that you would like, you can select and graph the data for it. This is going to be variation of the axial force along the length of the pile. Then you can copy and paste it in Excel or any other spreadsheet program that you have, and you can manipulate it later for any other presentation. Okay, so within this example, I only use the geometry tools that I had in RS3, and I use all these entities, solid, liners, and piles, and I develop these models for you. Sina is going to present something more complicated for you. Thank you, Sina.
Thanks, Alireza. Okay, let's look at the example that I'm gonna do. This is the part of underground mine. We have 2 drifts and 1 stope. To make it simpler, we have only 1 stope here. So this is the final model that we're gonna create, and I'm gonna start from scratch. So let's start from here. Actually, I'm gonna answer a couple of questions that we were asked during the presentation. One question was about the version that we are using. We are using Maintenance Plus version that Alireza is gonna show you the new features that we added to the software at the end. But this software is going to be released within a month. For this example, we have a couple of pieces of geometries that we're going to import, and we were asked a couple of questions regarding this as well. These are the formats. Let me take this off a little bit. These are the formats that we are accepting in the RS3 software. We were asked if we can read the DXF files. Yes, we have the DXF files. Any formats from any geological modeling software or solid modeling software packages, we can read it in the RS3 software. If the formats that you're looking for is not here, you can contact us and we can add it very quickly for you. Okay, I have 3 pieces of geometries, 2 drifts, and 1 slope. I'm gonna import them to the software. As I explained before, first let's add them to the software. You can do post-processing actions, including simplifying triangulations or repairing. You can do it either here or click on Done, bring the geometries in the software, and then do it one by one. So what I'm gonna do, or you can do it together, but I'm gonna do it one by one. Go to Geometry, Repair Tools, click on Repair. The software is gonna check for problems and defects. You can see that it found a couple. The most important one is the non-manifold one, and I'm gonna click on Repair. It's very quick procedure. The software is gonna fix the issues, and you can see they are all 0 here. I'm gonna do it for the next one. The same procedure, click on repair. We have different settings for repair as well. Normally 99% of the time the default option is enough to fix all the issues, and then the stop. Okay, so all these are fixed. The best practice is always to look at the triangulation of the surfaces to make sure that they are not dense, they are not bad. So we go to View, click on Show All Edges, and I'm gonna go to this view. For the drifts, you can see that the triangulations are uniform and the size is okay. But if I click on the stove, you can see that it's actually quite dense, the triangulation. So you can change the triangulation in the software. Just go to Geometry, Surface Triangulation Tools, click on Retriangulate. And instead of using medium option, if you use low option and hit OK, the software is gonna do the retriangulation, and now you can see that it has the same triangulation as the drifts. It's a very simple procedure. Next step is to add one external box. For underground mining problems, you have to make sure that the box is large enough, because what we assume in the software is that the tunneling is way below the surface of the topographic surface, so the box has to be large enough to prevent any effect on the drifts and stops. So what I'm gonna do, I'm gonna use different expansion factors for horizontal, for X and Y. For Z, I'm gonna use the expansion factor of 4, and now if you look at the geometry, you can see that the tunnel is far away enough from the different surfaces. If I hit OK, this is the geometry that it created. I'm gonna hide the triangulation so that we can see the geometry better. Since we are doing couple of excavations, I'm gonna add a couple of stages as Ali Reza showed before. So we're gonna have 4 different stages. It's draft 1 excavation, stage 3 is draft 2 excavation, and stage 4 is stop excavation. I click OK. These are different stages that we have. For draft 1 excavation, we click on draft 1, we change the material to no material. Draft 2, next stage, and the last one is the stop. The material that we are using in this example is generalized hook brown with the compressive strength of 100 and S parameter of 0.001, and also the stiffness Poisson's ratio is 0.25 and Young's modulus is 60,000. So these are the material models. So as we can see here that there is a lock in front of the external, but the other pieces there is no lock in front of them. We do the divide all procedure to make different pieces of material using these drifts and stop. I use the default option. We have different options for different actions that we have. Normally we use the default option, and the procedure is quite fast. It's creating different pieces of volumes. We have started with 4 different entities, but we have more here. Sometimes where you have a complicated geometry, you may end up with some small pieces. There are different ways of cleaning up this geometry. I'm going to show you 2 of them here. If you go to Geometry, Repair Tools, and Collapse Material Boundaries, what this option does, it's going to look at different pieces of geometry, go to different stages, and the ones that have the same role and the same material property in different stages, it's going to union them. So it's going to glue them together. If I click on this option, you can see that we have only 5 pieces now, and you can see it said union. So it union different pieces. But still, we have a small piece here that we don't need it. It might be problematic when we do the mesh. We go to Geometry, Repair Tools, Collapse Small Volumes, and we click on this piece and click on Collapse. And you can see that this one is gonna disappear. So if you look at the geometry, here we have drifts, stope, and the external box. The next step is loads. If we go to loading option, field stress, because this is an underground mine and it's deep enough, the stresses on this, the field stress should be constant. You can apply different field stress, sigma 1, sigma 2, and sigma 3, and also you can define different orientations for sigma 1 and sigma 3. I've already added these, and you just need to click OK. The next step is restraint. We have different options. For this one, we're going to use auto restraint underground. When you use auto restraint underground, the software is going to fix around this external box because it's deep excavation, and we are limiting X, Y, Z movement around the box. The next step is the mesh. So we use the 4-nodal tetrahedral mesh, which is graded, and you just need to click on mesh. The mesh procedure is quite fast, and it's going to create the mesh here for you. We have a grading with the graded mesh. It means that when you have drifts or stopes and excavations around those pieces, our mesh is finer, and as you go further, the mesh size is going to be larger. Let's look at this. For example, we look at the XY plane. If we zoom in, you can see that the mesh size around the excavation is very small, and as you go further back, it's going to be larger. So the size is good. Click on done, and I'm going to save the file. And the next step is to compute this model. We click on compute. If you look at the bottom here, when we mesh the model, you can look at the number of nodes and number of elements. And you can see that for this model, number of elements are 198,000. And it's a small number. And you can see that the procedure, because we have 4 stages, it goes through 4 stages, but each stage is quite fast. What the software does, it's gonna find the solid tolerance, and if the solid tolerance is less than this maximum tolerance, the model converges. So this is the last stage, and it's done. To look at the results, we can go to the results tab or click on this computed results available. We're gonna look at the excavation contours. We click on show excavation contours. Let me hide the external and zoom in. This is our excavation contour. If we go to different stages, you can see we have a stage excavation, and you can see this contour. One of the ways to look at the this is the contour actually for sigma 1. We have different ways of looking at the results. We can add different contour planes. Let's add one XZ contour plane. If we look from the top, we can use this freehand tool and move this plane to around the stove. Click OK. Let's add another one, which is YZ. Again, let's move it to the location around the stove and click OK. And I'm gonna look at the total displacement. So what we have here, we have total displacement contour for drifts and the stove, and also we can use these contour planes to look at the displacement around the tunnels and the stove, which is very important. Another feature that we have in the RS3 software to show the results is Isosurfaces. Isosurface is the way to show 3D contours with the same value of the output variables. For example, to show the extent of the failure with the same value. So if I want to add Isosurface, I use this option. You can use different output variables, or you can define it in the user data section. Let's define one stress difference data, and let's add the equation as S1 minus S3, sigma 1 minus sigma 3. If I click on display, the contour is gonna show the stress difference that I defined, and the legend on the right is gonna show the value that is changing. So after displaying, you can see the contours. So let's add one Isosurface. Let's say we want to look at a stress difference. We have different options, but this is the one that we define. We want to look at the stress difference of 5 MPa and see where along our geometry we have this stress difference. I'm gonna use a custom color, and I'm gonna hit OK. So what the software does, it's gonna create contour, 3D contour surfaces with the stress difference of 50 MPa. And this is our Isosurface. The pink area is the area that we have a stress difference of 50 MPa, and you can see that it's almost around all of our tunnels and stop. So Alireza is going to continue the presentation, and we're going to come back with the questions.
Okay, going forward, as for the company, we have launched the Maintenance Plus program. With this one, the main feature is that you have a continuous software update, meaning that as the features are being developed here at Rocscience, they will be released and they will be available to our customers. So for example, many features, the new features that, for example, we developed for RS3, like all the advanced material libraries for consumer modeling, similar to RS2, these are going to be available. All the new tools that we have for geometry, tunnel sequence designer, all the new meshing features is going to be available to our users as they are being developed and released. So with that, we will conclude this presentation. We will go over the question and we will try to answer as many as we can. Let's look at this here. There are a bunch of questions from the top. I think some of them Sina already answered. For meshing quality, let me bring up one of these models that we had before. So within the mesh tab, we have the option of mesh quality. If you select that, it is going to tell you how many bad elements, for example, you have in your domain. The model that I created, for example, at the beginning, it has 123,000 elements, only one bad element. And so this is okay to run and simulate it in finite element. If the numbers are going higher, we have too many bad elements, probably your results will be influenced by that. The main aspect that is controlling the mesh quality to begin with is the geometry. So if you fix your geometry using all the geometry cleanup tools, you're helping your mesher algorithm, and then you will have better results. How can you briefly explain what do non-manifold defects are? These are mathematical terms that the people in geometry use. To me, as a geotechnical engineer, this basically means that this piece of geometry cannot exist in the real world. How will the software deal with soil packets in borehole manager? So the borehole manager is going to define your initial geology, but like the same example that we were looking at it here, the tunnel was not part of the geology. The tunnel was another piece of geometry. I brought it in. It was interacting with all the other pieces. Then if you have any soil packets, for example, you can define the geometry, and later on you can assign a different property to that piece of geometry. In case that the software can't run the calculation fully. So if the simulation is not going to be run properly, we have options of, let me show you here in the project setting, stress analysis. We have the option of aborting calculation when the problem is not converging. And also, if you go later on in the log file, the engine log file, it is going to tell you if there was a problem with the simulation or not. And we will be working on a model check algorithm routines, so that before even running the engine, finite element engine, if there is any modeling issues, we can detect it and report it to the user before actually running the calculation. Does the tunnel design sequence, does stage excavation, shot grid, and all that? Yes. When it's going to be available, I think by the end of the month, when the software is available, we will do the sequence of excavation will be done, and also with the sequence of excavation, you can stage your supports, and even the composite supports that you are defining, they will come as staged and defined by the tunnel sequence designer. Okay, thank you very much. Thank you for your attention. It was a pleasure. And
one announcement, our next presentation, our next webinar is going to be in 2 weeks about seepage analysis using RS3 software, and we have another one after. So hope you enjoy this one.
Thank you very much, guys.